say, yeah, buy the meat that you can afford. Sure, there may be benefits also from animal welfare. I think that's pretty clear. If you buy, and that's not always the case. I don't want to pay robust because I've also been to grass-fed beef farmers. It was like, the animals probably a little bit underfed because you're there in June and it's completely overgrazed. And there's just no fresh forages for the animal, and they're maybe not looking as good. So it's there's always nuances, like maybe the farmer you described, but in general, yes. I mean, I'd say buy the meat that you can afford, and I'm not by any means it's something I often grapple with because if I look at the data, I'm thinking like, okay, this grass-fed beef is more nutrient dense. The animal looks metabolically healthier. It is clear. If you can afford it, absolutely do it. But we don't want to turn this into some sort of elitism either, right?
Right.
So I think if you are, hardworking family and you want to feed your children some healthy animal source foods, then buy what you can afford. And I think the main thing you want to do there is eat whole foods.
Yeah.
And don't take your kids to of course, it's fun to go to a fast food outlet sometimes, but don't make it every night and every lunch.
Yeah, no, that's great advice. I really appreciate that opinion. Speaking of meat and ground beef in particular, you've done some studies where you've looked at those two things, but also compared it with, the kind of again, fake meat. We'll just say fake meat companies that are producing food. What things have you learned about the difference between real ground beef versus a product that's made from plants to appear like ground beef?
They are as different as you expect an animal and a plant to be.
Okay.
So they're very different.
Okay.
Yes. Might as well study the carrot and an egg or something like that to an extent, because, it's important to note, now I jokingly say that because I haven't actually compared a carrot to an egg, but what we find a 90% difference in metabolite abundance. So sure, some plant-based meat alternatives, like in terms of amino acid composition and total protein amount, they may be similar. Some companies add vitamins and minerals to their products, so you might see some similarity in there as well. Though if you we found different amounts of different forms of vitamin B3, even though the package says the same amount. So there's some nuance to that, but it is really, once you go beyond the nutrients that appear on nutrition facts panels, those 50 nutrients, and you look at a broader array of nutrients, then you can find things like taurine, creatine, anserine, glucosamine, 4-hydroxyproline, only in animal source foods. And we studied soy-based plant-based meat alternative. We only found soy isoflavones in there. We've only found other phenolics in there. We only found vitamin C in there and things like that. So they are as different as you expect a plant and animal to be. So while they may be, and this is something subjective, but while they may be good sensory replacements, someone had once made me a vegan lasagna with an Impossible burger, and I could not tell it had an Impossible burger. Could have fooled me.
Yeah,
I just knew because the couple was vegan that it probably wasn't meat. So that they later disclosed to me. So maybe it could be a good sensory experience. But it's not a one-to-one nutritional replacement when you go beyond sort of proteins and fats.
Yeah, going beyond proteins and fats. It looks impossible that it would be the same as a ground beef burger. Soon I did that. So what about protein? Everybody talks about protein, and there's this claim now against Beyond Meat, or Beyond Burgers, excuse me, where they claim there was more protein than is actually in the ground beef, the fake ground beef that they make. Is that something you found as well?
Yeah. So what we found is that we did it for. We standardized it for 4 ounces of meat. So we actually found a little bit more protein in the soy-based meat alternative. So we didn't study Beyond. We studied the popular other one, a soy-based meat alternative. The name is out of the paper, so that's why I'm absolutely saying it. But anyway, the other one. So we studied that, and there was actually higher protein content.
Oh, interesting.
In the it was by 2 grams or so, but we just standardized it for fat. That's what we did. Yeah. So we standardized it for fat, and then so it had a little bit more protein. I think 2 grams more. The fat was the same. Total fat, I think, was like 15 grams or so. Yes, it was 15 grams. 12% was when we just wanted to. We had to match it on something, and we matched it on fat because we're also interested in more fat soluble nutrients, essentially.
Yeah.
So we did it, standardized it for that, and so the amino acid content was largely similar, or we know that soy, there was some difference in essential amino acid composition, but it's probably not very meaningful. We found the major differences in the things like that do not appear on the nutrition facts panels, because we always think of amino acids, right? And we think of essential, non-essential amino acids, but there's a couple hundred amino acids. So, or amino acid derivatives, things like taurine or creatine, which are peptides actually, but linkage of several amino acids. Those things were different for sure. So there's where we saw this big difference in compounds.
Yeah, gotcha. So interesting. So tell me about your research here at this facility. This is such a cool setup. Can you kind of describe what it's like to be in this facility, and how, you and I, we toured different floors of the facility, and the main floor has a little kitchen and place where people can pick up food. Tell us a little bit about your current work here.
Yeah, so the work here, I started here a year ago in the Center for Human Nutrition Studies at Utah State University, and where we're sitting now, it's downstairs, and downstairs we have indeed a clinical research facility. So we have 5 exam rooms, we have a big phlebotomy lab, and sort of a welcoming sort of front desk. So that's why I say it looks like a doctor's office, like you visit that. Then we have a metabolic kitchen as well, and some dining facilities. And then upstairs we have a wet lab facility. So where we do a lot of, we actually take the blood of people, or urine, or stool samples as well. And then we analyze them. So what are the impacts of different dietary patterns or different foods on inflammatory markers, on the compounds that circulate in their blood? Because we know that roughly about 50% what circulates in our blood is directly related to the foods that we eat. So there's a half truth to the saying, you are what you eat.
Yeah.
So that's something we are studying often. So one thing that we're doing now is, okay, if we've done this profiling on plant-based meal alternatives and meat, and we find very much different profiles. What if we feed people this? Does what circulates in their blood differs after eating those products, right? Because one contains taurine, one contains creatine, the ground beef, the other contains soy isoflavones and other phenolics that are not found in either or, right? Can we see some shifts in what circulates in our blood afterwards, beyond just amino acids, right? Because yes, protein is very important, but it is only part of the reason why we eat foods. So that's what we're doing in those studies. So we have a processing facility upstairs, like a wet lab, which you think of people in terms of like when you look at a laboratory, essentially. So that's what it looks like. And then across campus we have a mass spec as well, and we do a lot of our analysis there. So what a mass spec can do is it can look at a large number of individual compounds. If you know the mass of these compounds, so each compound, let's take leucine as amino acids, or we take vitamin B6, they have a unique molecular structure and a unique molecular mass. So you can measure those on a equipment, and it's the same what people use for drug testing with athletes, or even drug testing for legal purposes. So, and what we use it to measure nutritional compounds in foods and subsequently in people. So that's mainly the 3 pillars of our work. And then we work with various local farmers, and then there's also a big animal research facility around here where we do some work with cattle. And we have a study going on milk and different forages. And then we also do some work in crops as well, like different fruits, also like different growing practices in fruits.
Yeah. Wow. So to me, it seems like you're answering the more important question. It's one thing to know what is in the food, but more important is we want to know what is acutely happening a few hours after we eat our food, and that's what you're measuring.
Yes, in one of the studies, we do both acute and long-term studies. Acute studies is nice because you can just feed people a burger or a meal, and then you can measure what's in the meal, and then you can measure what's in their blood. And we've done studies in the past, these tracer studies, where you can detect amino acids from the food source already after 15 minutes in someone's blood. Wow. So if you eat an egg, then 15 minutes later, we can start measuring those amino acids from the egg in your blood.
Wow.
So we do know that there's these shifts, and we've done some work on fatty acids as well. And there's been some elegant work from a group out of Switzerland that has done some work with yogurt and milk. And you can kind of see if you overlay the yogurt metabolome, so what's in the yogurt with what's in people's blood, your blood kind of starts looking like yogurt a little bit, if that makes sense.
Yeah.
Or at least the compounds in yogurt, right?
Yeah.
And there's some unique fermentation compounds in there. So you can measure those things. Obviously, you cannot say anything about long-term health from a study with a few hours, but you can start to link what is in our food with what subsequently ends up in our body. And then we can do multi-week or multi-month feeding trials, randomized controlled trials, say, okay, if we then repeated this behavior or this for several weeks or several months, can we measure some shifts in biomarkers of your metabolism? Do you have different amounts of cholesterol, triglycerides? What does your fatty acid profile in your blood look like? Can we shift it towards more long-chain fatty acids? What about glucose metabolites, right? Which gives an indicator of like probably future diabetes risk.
Yeah.
What about your mitochondria? Are you more efficient in relying on oxidative metabolism because of the food sources that you eat? Because we know that if you eat more long-chain, if foods such as grass-fed beef contain more long-chain acylcarnitines, long-chain acylcarnitines are responsible for transporting fats to the mitochondria where they can be used for energy production. So can we see shifts in that in the blood of people? So those are things that we measure. Obviously, as sort of a interventionist as opposed to an epidemiologist, I don't do epidemiological studies. I wasn't trained in that, and so we cannot measure hard outcomes, as I mentioned, but we can measure biomarkers that we then try to relate to other randomized controlled trials or epidemiological research, right?
That's right.
So